right, here's number 4 on the limiting reactant practice and percent yield packet. So this one is getting into percent yield. So here's what we're rolling with. It says consider the combustion of 215 grams of butane, which is C4H10. So that's how much I'm starting with. Plenty of oxygen. So that means excess oxygen. If you are able to collect, so to me that means if I'm actually able to collect 295 grams of water, what is the percent yield? So what I just highlighted in blue is my actual yield, right? If I'm actually able to collect, if you are, nope, that's not right. Let's try to make that normal size. There we go. Actually able to collect 295.3 grams of water. So I'm actually going to save that blue highlighted number for the very end. So now let's start doing our BCA table. We know, let's do, luckily this equation is balanced for us, which is the first step always is to balance the chemical equation. This one's balanced because I see those big coefficients. And then they gave us 215 grams of C4H10. I'm not allowed to put grams in my BCA table, so let's go from mass island to mole island. So I want 1 mole on top. I want grams to cancel. So we need to find the molar mass of C4H10. So I'll take 4 times 1.01 plus 10. Oh, yikes. Let's try that again. 4 carbons, so 4 times 12.01 plus 10 times 1.01. That gave me a molar mass of 58.14. So that 58.14 goes on bottom, so we are dividing. 215 divided by 58.14, that gives me 3.7 moles of C4H10 to start. B, C, A. So we got 3.7 moles of this guy, and because they said plenty of oxygen, that means this guy's excess. So before the combustion happens, there is no CO2 made yet or no water made yet. So now we go through and we say minus 2x, minus 13x, and then this one will be plus 8x, plus 10x. Off to the side, I'm going to find my x, and so we're going to take 3.70, this guy, divided by the coefficient 2. And when I do that, I get 1.85, and then I'm going to do the same, so that was C4H10. I'm going to do the same for O2. Excess divided by 13. Excess divided by 13 is still going to be excess. Smaller is obviously 1.85, which means he's my superstar. So we'll plug in 1.85 over and over again for all of these x values. And now we can solve. So 3.7 minus 2 times 1.85 gives me 0 moles remaining. Excess minus 13 times 1.85 is still going to be excess. 0 plus 8 times 1.85 gives me 14.80 moles produced. And for water, we got 0 plus 10 times 1.85, so that's 18.5 moles produced. In order to find percent yield, we have to take our actual divided by the theoretical, and then we times it by 100, so it's a nice percent. We have the actual yield given to us in the problem. We need to find the theoretical. Well, in theory, right, based off our number crunching without actually touching any chemicals, you and I said that we need 18.5 moles. But I want to get this into grams because in the problem they gave me the actual yield in grams. So we're going to go from 18.5 moles of H2O to grams of H2O. So we need the molar mass of water. I got 18.02. Sorry, I forgot my units. Okay, so really we're taking 18.5 moles times 18.02 grams. That's going to give us 333.37 grams H2O produced in theory. So finally, now that number we've been ignoring in the problem, if we were actually able to make 295.3 grams. So not in theory, I actually did this combustion reaction, collected the water, put it on a balance, figured out it weighed 295.3 grams. Compare that to the theoretical that we just calculated, 333.37 grams times 100. That will give me my percent yield, and I got 88.6%. Hopefully that was helpful.